Right, for lesson 3 of our statistical displays, we're looking at box plots. So again, we are really just going to be focusing on, if you're given a box plot, how to interpret it, not necessarily creating it on your own. So a couple things we need to know. A box plot uses a number line to show the distribution of a set of data values by using the quartiles, the median, and the extreme values. So we'll explain what that means. Okay, so here's an example box plot. It's also sometimes called a box and whisker because you kind of have this box in the middle with little whiskers sticking out. So we have quartile values, which is talking about our Q1 and our Q3, right? Those quartiles. Upper quartile, lower quartile. We have our median, which is technically a quartile too, just in the middle of the data. And we have our extremes, which is just, okay, this is our low value and this is our higher value, okay? So these values split the data into 4 equal parts. And if we have 100% divided by 4, that means that each part is representing 25% of the data. So really, we have this first portion here, which is our lower extreme to our Q1. This is 25% of the data. We have the next portion, which is right here. That is our Q1 to the median. This is also 25% of the data. We have this next range, which is our median to the Q3. This is also 25% of the data. And then we have our last one right here, our Q3 to the upper extreme. This is also 25% of the data. So it's split into 4 parts, part 1, part 2, part 3, part 4. They have the same amount of data values in it, just some are more spread out than the others. So let's look at interpreting a box plot. Number 1, a restaurant recently collected data to see how many minutes their guests waited for a table. The data is presented in the box below. Use the plot to answer the following questions. So, first thing we're going to do is I'm going to label. So our lower extreme should be our first value, which is right here. That is in between 14 and 16, so it's at 15. The next dot here should be our Q1, our first quartile, which is at 24. The next dot, this line in the middle of our box, that's the middle of the data, or our median. Here it's between 28 and 30, so it's at 29. Our next dot is at the other end of the box. It's between 32 and 34, so it's at 33. And then the last dot is in between 34 and 36, that's at 35. So this was our Q3, this was our upper extreme. Okay. So now remember, we have 4 different ranges that we're looking at. We've got this first range, the lower extreme to the Q1, that is 25% of the data. We've got this second range, our Q1 to the median, that is representing 25% of the data. We've got this third range, our median to the Q3, which is 25% of the data. And we've got this last range, our Q3 to our upper extreme, which is 25% of the data. So which of these ranges is it the most clustered? So key word here is clustered. That means I think of like it's close. So which ones, and I'm going to put it the closest, maybe in parentheses to help you. It's going to be our smallest range. So you might be able to look at it right now and tell me, you're looking here, which of these looks the smallest? Right now it looks like this value right here, but I'm going to double check by just writing in the distances, okay? So from our lower extreme to our Q1, 24 minus 15 is 9. This range right here, 24 to 29. 29 minus 24 is 5. For this range right here is our median to our Q3, 29 to 33. When you subtract that, you get 4. Hard to see that. And then this last range is our Q3 to our upper extreme, 33 to 35. You subtract that, you get 2. So, yeah, our suspicions were right. This looked like the smallest. That has a range of 2 that is the smallest. So that was the range from our Q3, which was at 33, to our upper extreme, which was at 35. So we're just writing the range that it was our Q3 to our upper extreme. All right, for B, for what range are the data the most spread out? So again, which one looks the biggest? Right here, and that is the biggest difference between the two values. It is this range right here, which is our lower extreme to the Q1. What is our IQR? We're just doing our Q3 of 33 minus the Q1 of 24. What is 33 minus 24? We get 9. What percent of people had to wait over 24 minutes for a table? So what percent of people had to wait over 24 minutes for a table? So I'm going to find 24 here, which I see right here. So how many had to wait over 24 minutes? So that means higher than that amount, greater than 24 minutes. So we are going to start from this point and we're going to add the percentages that are higher. So we have 25% here, plus another 25% there, which is 50, plus another 25% there, which is 75%. What percent of people waited less than 29 minutes for a table? So I'm going to find 29 on my graph, which is right here. Less than means anything smaller than. So I'm going to add up the percentages that are smaller than, which is to the left of 29. So we have 25% plus another 25%, which is a total of 50%. So it's going to be either 25, 50, 75, or 100% to answer this question here. All right, number 2. Listed below is the lengths of the winning distances in the women's Olympic shot put event. So we already have the box plot for you here, okay? I put the numbers in so that you would see if I were to calculate my median, I'd have these two numbers here. Our median would be 68, which is the middle of this whole chart here. Then I would go back and I'd find my Q1. I'd get these two values. The average of those is 67, which we see right here. That's our Q1. Same thing on the top. We'd find our Q3, which is in the middle of 68 and 72, which is 70, which we see right here as our Q3. Our lowest number gave us our lower extreme, and the highest number of 74 gave us our upper extreme. So you don't need to do anything with these numbers. I was just showing you how we got this chart from the numbers, okay? So all we're using is the chart. Our lower extreme, we see that it's at 65. Our Q1 is the left side of the box. That is 67. Our median is the line that goes in the middle of the box. So that is at 68. Our Q3 is the right side of the box. That's 70. And our upper extreme is just the highest value there. So again, looking at our ranges here, we've got range 1, range 2, range 3, range 4. So where is it the most clustered? So that should be the closest, the smallest, which to me looks like right here, but I'm going to double check. The distance from our lower extreme to our Q1 is, you can count on the graph, 1, 2 over, or you can subtract these two and you get 2. For our Q1, the distance from 67 to 68 is 1. From 68 to 70 is 1, 2. From 70 to 74 is 1, 2, 3, 4. So where is it the most clustered? The smallest is this range right here, which is our Q1 to our median. Then the second part, where is it the most spread out? The largest spread is right here, which is our Q3 to our upper extreme. Let's try one more of these. The number of goals scored by Blackhawks players in the 2012-2013 season is shown in the table below. So we do have it in order for you. You don't need to go through this crossing off to figure out these measures. It's already graphed for us here. We're going to use that. So remember, it's our lower extreme, which is right here. That is 3. Next is our Q1, which is at 6. The line in the middle of our box is our median, which is at 8. The right side of the box is our Q3, which is at 14. And the high value is our upper extreme, which is 23. Then for answering the second part of the question, we're looking at these 4 parts. Part 1, part 2, part 3, part 4. Alright, so we're looking at the distance. This is 1, 2, 3 apart. This is 1, 2 apart. Right here it's 1, 2, 3, 4, 5, 6 apart. And right here it's 1, 2, 3, 4, 5, 6, 7, 8, 9 apart. Again, you can do counting or you can subtract the values. So the clustered is the closest. So which one's that smallest separation is right here, which is our Q1 to the median. Q1's the left side, the median's the right side. Where is it the most spread out? Right here. It starts at the Q3 and it goes to the upper extreme.